This is Geometry, Semester 2. It's the unit on conics. It's 7th unit. And it's the lesson on hyperbola and parabola practice number 3. It's on creatormath.com. You might have to type in creatormath.weebly.com into Google to find it. And it is under the Geometry tab. The instructions are copy the following problems 1 through 17 into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Couple notes here. There are more problems on the page than 17, so when it says a number like this, 1 to 17, only do those in your comp book. There's a lot more, but they're not necessary, all right? And the other thing is, I'm going to show you notes right now on creatormath.com. I already have it up here. You might have to put in the Weebly, creatormath.weebly.com when you search it on Google. This is what the home page looks like, creatormath.com or creatormath.weebly.com. We're under the Geometry tab. That's where all the notes for geometry are. You're going to pass by the vocabulary, get down to the table of contents. So this is table of contents. It's on page 2 through 6, or you're going to write it on page 2 through 6 of your comp book. And we're in semester 2. You're going to write all these line by line. Write them in, write every line, and what you're paying attention to is the page numbers for each one. Those page numbers establish where in the comp book they go. So this is trigonometry, special right triangles, pass by all this. We're going to go all the way down to conics. And this is conics here on hyperbola and parabola. Don't use the page numbers on this video right here. Go back and look at the actual table of contents on creatormath.com because by the time you watch this, it'll probably be different page numbers, right? But there's a notes associated with this lesson. Sometimes you have to open the notes a couple times because it takes a second for them to load. There you go. Mine loaded first time, but I'm telling you it'll be different for you every time. So sometimes I have to load them twice. So we're looking at conic sections here. We've got an equation of a hyperbola. We're going to talk about that really quickly. And we're also going to talk about the equation of a parabola right here. So those are in the notes. Sometimes it'll be a picture of the board. Sometimes of my notes. You're going to copy these into your comp book. That'll help you do the problems we're about to do, as we'll illustrate. So let's go to the first problem here. It says conic shapes, which include circle, ellipse, hyperbola, and parabola, are produced from what figure shown in the diagram below. So this is a diagram, a figure here, which is a cone, and it's end to end with another cone. And that's probably the easiest way to think of it. So it's called a double cone attached end to end. That's a little bit colloquialism there, but that's what it is. All right. Let's go to the first one. If a double cone is cut by a plane, as in the figure below, what shape is produced? So if you look at all of these right here, we definitely have planes that are hard to see. A plane is a perfectly flat surface, which is infinitely thin and continues in all directions forever. And if you slice through this double cone end-to-end shape, we get a cross section. That means if you cut it and open it and look, we get a shape. This one produces a hyperbola. And it's this shape and this shape. This one produces an ellipse, which is otherwise known as an oval. A circle is produced if you cut straight through like this. And a parabola is produced if you cut at an angle here through one of the cones, and this is the parabola shape here. So we love it because it produces these shapes. We being geometry teachers, or math teachers, sometimes you're going to learn this in Algebra 2. This is just a brief introduction in geometry. So as we cut through this one here, we are producing the hyperbola, right? So remember it's spelled hyperbola. We're going to say it hyperbola. We're going to spell it hyperbola. So if a double cone is cut by a plane in this figure, what shape is produced? So here it is here, and this is the parabola we're talking about. And that's the two cross sections we're going to be looking at in this lesson. Problem number 4 here. Make sure it says 4 on your paper. Which of the following is an equation of a hyperbola? Well, if we do go back to the notes, because it's kind of hard to answer this without the notes, you could always just Google it, by the way. But here we are. This is an equation of a hyperbola. It's x minus h, quantity squared, over a squared minus. That's an important part, that minus right there. y minus k, quantity squared, over b squared equals 1. And these have different parts. H, k is the center. We're going to show that in a second. A is the radius in the x direction. B is the radius in the y direction. It's always equal to 1 if it's a hyperbola, and it's always got a negative between the two terms on the left side of the equation here. That tells us it's a hyperbola. If it's an addition and it's equal to 1, that is an ellipse. So we have to use these little clues to tell us what type of equation we're looking at. So here's a diagram that spells out where everything goes. There's a radius in each direction, but let's just do it looking at one of the problems. So here, let's get this done. We've got x minus h squared over a squared minus y minus k squared divided by b squared equals 1. Go slow as you're looking at these. They are like a cryptic, language, like a code you got to look at, and go slow. Let your eye read them. So here's our first hyperbola. Problem number 5. The hyperbola shape is this one here, and this is the cross section cut out of the cone that we've already discussed, the two cones together, end to end, called a conic shape. And we have several things going on here. There's this center rectangular box that helps us map this out. There are these guidelines that run here through the corners. All right, and we have a center to this box. The center here is, let's find its location. It is 1, 1, 2. 1, comma 2. Right? So in our formula, we know that's HK. So they're even just walking us through this. All it says is, what is the center of the following hyperbola? Okay, and it's 1, comma 2. 1, comma 2. We're just finding the coordinate location of the center of that box that lays out the entire shape or cross section, known as a hyperbola. So here's another. Let's look at the center again. They keyed us in on that. Let's do it again on this one. The center here is minus 1, 2, 3, 4, 4. Minus 4, comma, and it's down 1, 2 on the y, so minus 2. That's our center. We also have a radius arm here, which is along the x, and a radius arm here, which is along the y. Let's map out the entire equation. The equation is x minus h squared over a squared minus y minus k squared over b squared equal to 1. And now we have the h and k are x and y of the center of the hyperbola. So we're going to drop those in. X minus a minus 4 goes to x plus 4. A is the radius arm along the x direction, so it's here. This is 1, 2, 3. So 3 squared here, minus. Now we're going to do y minus k is the y value. So minus a minus 2 is a plus 2. We're squaring it. B squared is in the direction of the y, is the radius arm. So 1, 2, 3, 4, 5. It's going to be 5 squared, and this is always equal to 1 for a hyperbola. So the only thing we can clean up is square these and make this a 9 and this a 25. But let's go right over here and choose the correct equation for this hyperbola. And definitely what you want to do, because you're looking at this whole thing going, what are we even talking about here, right? What is this we're looking at, this hyperbola? So the best way I feel to, get involved in this is go straight to desmos.com and let's type in this equation and see what it produces. So we have an x plus 4 squared divided by 9. We're going to use what I got here and just modify it. X plus 4 squared divided by 9. There we go. Let's get rid of all this, or let's make this a minus. Let's get rid of this, 2. And we have a y plus 2. We've got a squared on it. We also then have a divided by 25. And this is all equal to 1. And look at that. This produces the hyperbola that we're looking at right here. See the red? And see this one here? Right? So maybe this helps you understand that if I just type this crazy looking, equation into my Desmos, it'll graph it for me. No plotting points anymore like in the old days of learning to graph. You're just going to go straight to a grapher and let yourself see what it looks like straight off the bat. So please exercise that patience. Use Desmos as you're going through this. Try at least one in Desmos, and if you need to, graph them all. If you sit there saying, I don't understand it, then graph every single one in Desmos. It's going to help your brain digest what you're looking at. So this is interesting. The center of this one's at 0, 0. Right? If it's at 0, 0, then you notice the terms x minus h, here's our original formula each time, minus y minus k squared over b squared equal to 1. If h is 0, right, this goes to 0, and this goes to 0. They disappear. Now I'm just left with x squared over a squared. Well, what is a? A is the radius arm in the x direction. 1, 2, 3, 4. So 4 squared. Minus, if this is gone, it's 0, it's just y squared. Over b is in the radius arm in this direction. Looks like 1, 2. So that's 2 squared equals 1. So here we have 4 squared is 16. Check. Here we have our x squared, our y squared. 2 squared is 4. Check. It's that one. Now remember, my answers always come up A on my answer sheet. When you're taking this assignment, yours are randomly mixed up, so you're going to have to look a little bit, right? But you have the answers to them, so it shouldn't be that difficult. Here's another one at 0, 0, so I can expect no second terms. Oh, look at this. We just switched from, let me do that prior. Okay, just looking. Notice the way the hyperbolas open. They open along the x-axis in the prior problem. Now all of a sudden, look at what happened. They're opening on the y-axis. This is a big change. So notice what has happened. What was before the x values here in this location, now the y values, these two have swapped places in the equation. And now that we've done that, our hyperbola is now opening upward and downward according to the y-axis rather than before on the x-axis. So now the equation changes. Instead of being x minus h, it's y minus k squared over b squared. Minus, now it's the x minus h. So these two trade places here and here, these two terms around this negative or minus. This is a squared equals 1, x minus h, y minus k. Let me check them, because my brain starts, when I start mixing things up, right? That's when you see me do that on video. It's because I'm swapping things and I'm not taking enough time to concentrate to do it. So in this case, this one's 0. This one's 0. So we're going to end up with y squared over b. b is in the y direction, so let's start here. This is our radius arm 1, 2, 3, so it should be 9. Check. And this radius arm in the x direction is now over here. It switches 1, 2, so 2 squared is 4. Check. This is our equation of this hyperbola opening along the y-axis. All right, this one goes back to the original orientation where it's along the x-axis. So let's just check the radius arms. Let's just go here, 1, 2, 3. 3 squared is 9. Check. Radius arm, and this is again the box we use to draw this whole thing. 1, 2, 3, 4, 5. So 5 squared is 25. Check. So now they switch us to the parabola, which is kind of hard to do two shapes in one lesson, but that's the way we jammed it in here, so sorry about that in advance. But now we're switching to a parabola, spelled parabola, right? Parabola, but you're going to say it, parabola. X minus h squared equals 4p y minus k. Check back with your notes. Number hyperbola, here it is, notes. I guess I lost it. It's going to open back up. Come on. Do I just have it somewhere? No, I don't. There it went. There it opened. All right, so let's look at the notes on the parabola. We've got x minus h squared equals 4p parentheses y minus k. That is the equation of a parabola here. There's a focus, which is p away from the vertex, which is, I could get this a little bigger. It's so small, I'm sorry. This is the vertex of the parabola. Here's the parabola here. P has, there's also a directrix down here on this side. Copy the notes into your comp book and you'll see some of these different terms. The distance P is between the focus and the vertex and the directrix is the same distance P right here in our equation of a parabola. So they're asking us which opens up. This one opens up. This one opens down. This one opens right. This one opens left. All right, so that's what they're asking us right now, and I'm going to show you as we go. Here's the original one that we just looked at. Oops, go to here. Sorry about that, you guys. Here we go. X minus h squared. This is where we're focusing right now. There's no sign on the 4p. Once we go to here and we have a negative sign, this one opens upward, so the parabola goes like that. This one opens downward, so the parabola goes like that, and the key feature is a negative switches right here. This one, once we reverse the two terms, so y minus k is here on this side, now the y minus k moves to the left side of the equation, and all of a sudden this one moves, opens to the right. Okay, here, 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 and if we put a negative on this, and the y minus k is on the left side, then it opens to the left. Take your time, look at the notes. I know this is a lot to digest in the way I'm going over it. That's the whole point of having a video, though. Just watch it again. This one's now going to open to the left. So let's see if we can match up given parabolas with their equation. First of all, this one opens upward. So if I even just go back and look at my notes, just to show you as bad as these notes are, and I agree they're bad, just find the parabola that's opening up. I see it right here, right? This one is x minus h squared. So I've got an h and a k is the vertex. Let's map that out. Here's the vertex right here. And looks like the vertex is at 1, 2, 3, 4, 5, 6. So negative 6, parentheses, 1, 2, 3, 4, 5, negative 5. A little bit hard to see, but that's hk. So if I have x minus h, what am I writing here? X minus h squared, according to the formula in my notes, equals 4p y minus k. Oops. I just wrote on my screen. That's funny. And there's a squared on this side of the equation. There's not one on this one. All right, so let's go ahead and look. If you have an h of negative 6, it's going to be x plus 6, because a negative and a negative is a positive squared. Notice that's what I got right there. Check. Let's forget the 4p for 1 second here. Let's go straight to this one. Y minus a minus 5 is y plus 5. Check. Now I've got this 4p. The only way for 4 to end up being a 2 is if this thing, and I do apologize for this problem, because what you have here is they show you literally that this vertex is at negative 4.5, and the directrix is at negative 5. That's a difference of 1/2. So you're taking 4 times 1/2. 4 divided by 2 is 2. That's where this 2 comes from right there, 4 times p. A little bit of a struggle and a little bit difficult, especially given the graphics not so nice, and I'm not sure I would have started with this one again if I could choose over, but that's it, and it fits the pattern of the equation. Now, just on another note, let's go here again. What you need to convince yourself of is this equation of a parabola. So let's delete this out. I can just go delete. Let's do a new one. Parentheses, x minus 6, parentheses, squared equals 2 times, parentheses, y plus 5. Y plus 5, parentheses. Okay? Notice what we got. And I made a mistake. I hope you're seeing that from where you are. I made a mistake. Let me just point it out to you. Look at where my parabola is in this graph. It's on the right side of the y-axis. Look at where my parabola is in here. It's on the left side. And look at my parabola is, looks like down the right distance. It's just on the right of the y-axis. So let me check my equation again. It should be x plus 6. I did x minus 6. Let's correct that. And that's the other thing you want to do, is play around with these equations. Change signs, change numbers, and see what happens to the graph. Y plus 5, 2. So now this looks like the one I've got. And this, sure enough, is an equation of a parabola as demonstrated by what we did on Desmos. All right, with that done, let's see if we can move through the rest of these. This is a long set of problems. Which matches? Well, yeah, I got my picture still. Just look at the way the parabola is opening. It's opening down. I mean, let's help ourselves out a little here. This is an introduction to parabolas. I don't think you need to have these memorized, right? You're going straight to the notes, and you're saying, if it opens down, I have x minus h squared, and I look at this negative right here. This is key. So anything without a negative there is out. I need a negative for this to open down. I have one on this term and this term. So these two are options. Let's look at the vertex? The vertex is at, can I read my graph? Here we go. 1, 2, 3. So the vertex is at 3, comma, 1, 2, 3, 4. 3, 4. So we're going to have x minus h, which is 3. X minus 3, check. And we're going to have y minus 4, check. That means this one's out. So I know this is the correct answer. The distance between the focus and the vertex is 1, 2. So there's a 2. And it's 4 times 2, which is 8, and it's negative, which means it opens down. Check. All right, everything lines up. I know this is my equation. Plug it into Desmos. You take that time and go ahead and do it. All right, let's go back to our notes again. We're opening to the right. So y minus k squared. We have hk. Let's find the 1, 2, 3, 4. Looks like a 5 there. Oh, here we go. That's the directrix, not the axis. 1, 2, 3, 4, 5. So this is at 5, comma, 1, 2, 3. Y minus k, which in this case is 3, because this is h, comma, k. So we're going to have y minus 3, check. It's squared in the formula, check, equals x minus h, which is 5, so x minus 5, check. And 4p. P is the distance between the focus and the vertex, and the vertex and the directrix. It's the same. So let's count either one. 1, 2, 3, 4. So 4 times p. 4 times 4 is 16. Check. The only one they haven't asked us yet is one opening to the left. And sure enough, here's a parabola opening up to the left. So let's find the vertex again here. This looks like 1, 2, 2, comma, 1, 2, 3, 4, 5, negative 5. 2, comma, negative 5. Here we have a parabola opening to the left. Here's our equation. X minus h squared. So h is 2. So x minus 2 squared. Oops, I'm looking at the wrong equation. I'm sorry, you guys. Bad notes. When you copy these into your comp book, you're going to copy them in a little bit cleaner than I did on my paper. All right? That's the only excuse I got right now. Otherwise, I don't have a good excuse for this. So y minus k, this is the k value here, negative 5. A minus minus is plus, so we're going to have y plus 5 squared. There we go. Check. That looks better. We're going to go to the right side. It's x minus h, or x minus 2. Check. And we have a negative 4p. So the p in this case is, looks like 1 between the focus and the vertex. 4 times 1 is 4, and there's a negative, so that checks out. So remember, you're putting the notes in your comp book first. Put it on the right page according to the table of contents. Match up where you are. You're in Geometry, Semester 2, the unit on conics. This is the third lesson called Hyperbola and Parabola Practice. All right? It's on creatormath.com under the Geometry tab, and I hope this helps.